Today we're going to be talking about research designs, also known as research strategies. All right, so here's the roadmap for today. So first, we've been talking about descriptive versus inferential statistics, and we know that now we're talking about different ways of doing inferential statistics. So we're just going to review those again. Then we're going to talk about variables and relationships. There are different kinds of variables and different kinds of relationships you need to know about. Then we're going to introduce 3 different categories of research strategies or designs. And then we're talking about why can't other strategies besides the experimental strategy determine causation. And then we're going to talk about what is so special about experiments. Finally, we're going to end with some experimental terminology. All right. So we know that we've been doing a lot of descriptive statistics so far, looking at visualizing data, summarizing it, and we could do that for both 1 and 2 variables. Then we talked about why inferential statistics is different. Number 1, we're interested in generalization, and because of that, we covered some sampling methods that will allow our samples to generalize to the population. We also introduced the idea that we would like to have comparison in order to examine causation. We'd like to know whether one variable causes another, not just the relationship between them in terms of a regression line, but we'd really like to know, well, does one cause the other one? And in order to do that, we're going to have to learn about experiments. All right. But before we learn about experiments, it's going to be helpful to learn about other kinds of research strategies in addition to experiments, just so we could see why experiments are so special and different. But in order to understand those different kinds of research strategies, we're going to need to review variables and the relationships that they could have. So one thing you need to know about variables is that we've covered 2 broad kinds of variables so far. Categorical, categories as the variable levels instead of actual like numerical values, or continuous, where the values of the variables are numbers that are meaningful in some way. So an example of categorical variables are whether kids have pets or not, so the pet variable, versus continuous, which might be something like a score on a biology test. So then you could have maybe 1 through 100, and each of those numbers are meaningful. In terms of relationships, there's a bunch of different relationships we've actually covered. But all of those relationships so far have been descriptive relationships. So we've covered relationships such as linear relationships, curvilinear. We've also looked at relationships such as negative correlation and positive correlation, right? But all of those relationships are descriptive. They're just describing what the relationship is like. They're not actually telling you whether one variable causes the other variable. Those are causal relationships. They're not necessarily telling you that one variable doesn't cause the other one either, right? So this is a new kind of relationship that we're going to be looking at. Now, only one kind of study, one kind of research design can actually look at causal relationships. And that's going to be through the experimental research strategy or design, right? This is the only one, and so that one's pretty special. So far, we've only covered these other kinds of relationships. All right. So before we go on to the nitty-gritty of an experiment, it helps to know what are the non-experiments, right? So not every type of research study is an experiment. Just because you collect data on lots of variables doesn't mean you have an experiment. We need to start using that in a more narrow context. A lot of people, I think, especially in the media or press or popular press, they'll use it in a more loose way. They'll call anything an experiment. But usually we use that for a very, very specific kind of research strategy. So first, category 1 are are the kinds of studies that are only descriptive. So these are descriptive studies. The variables can either be categorical or continuous, right? But they don't look at any relationships. No relationships. So they don't even describe relationships between variables. They only look at variables in isolation. So they're really only interested in the distribution of people's heights or people's IQs or the distribution of bacteria in the stomach, right? So they're only interested in describing one variable or a couple of different variables, but not looking at the relationships between them. So that's very important. That's the descriptive study. That's category 1. Category 2 moves on a bit. Here, we're interested only in continuous variables. So only continuous variables can be used in category 2, no categorical ones. And here, the only relationship we could look at is descriptive. So here, because we have multiple continuous variables, we often look at these on a scatter plot. Okay, so those are called correlational studies, and that's category 2. Category 3 has 3 different kinds of research strategies in there. One is experimental, the other is quasi-experimental, and the third kind is non-experimental. So in these, you need to have at least one categorical variable. You could have also continuous ones and other categorical variables, but you need to have at least one categorical variable. And here, you could look at both descriptive relationships, but for one of these, the experimental one, you could also look at causality. But you cannot look at causality with quasi-experimental, not quite, not all the way, nor non-experimental. So even though you can look at causality within category 3 research strategies, it's really only experimental research strategy that can look at causality. All right, so in category 3, let's break down these 3 different types. So experimental research strategy, you know that you need at least one categorical. And that's actually the case for all of these. At least one categorical, at least one categorical. So that's what these 3 have in common. But for experimental, you could look at both descriptive relationships and causal relationships. You could look at both of those kinds of things. For quasi-experimental, we could look at descriptive, and we could actually sort of come up with causal explanations, but not quite. And that's why it's called quasi-experimental. Sort of look at causality. It gets close. It gets pretty close as you can be without actually being experimental. And for non-experimental, you can only look at descriptive. So these are the 3 different kinds. Quasi-experimental ones are also often called accidental experiments. Or one very common example is using pre-test and post-test, where you're looking at how something in the middle is causing it, but you also have sort of this confound where because you're testing people 2 times or you're measuring something twice, it might just be an artifact of measuring something twice, right? For example, if you wanted to know how good a math software is. You might have a pre-test and post-test, but people might just get better just because they did the same test twice, right? So that's why quasi-experimental, sometimes it has some issues. Non-experimental variables are going to be quite different from experimental categorical variables, and we're going to talk next about what the difference is. Okay, actually, before we do that, we're going to first talk about why can't the other strategies determine causation? Because it seems so exclusive for experimental research strategy. What's wrong with the other ones? Well, all of the other strategies have two fundamental problems that they cannot escape. So here's the big issue. We have some variable 1, and we want to know whether variable 1 causes changes in variable 2. For instance, let's say we want to know if having a radio in a developing country will lead to women having fewer children. So if your household has a radio, does it mean you have fewer children in your house, or greater use of birth control, right? So that might be variable 1, radio, right? And variable 2 might be something like use of birth control, right? And we want to know whether one variable causes the other variable. Because if we knew about causation and we wanted to reduce or we wanted to increase the use of birth control somewhere, then we could adjust radios in households. We could give people free radios or something. And then, and by doing that, change the use of birth control. But it would be nice to know whether this causal relationship actually exists or not. Now, one thing you could do is, ask people whether they have radios, and then ask people how much they use birth control, right? Whenever you do studies like that, and that would largely be a non-experimental design because this is a categorical variable, radio, no radio, and maybe use of birth control might be how many times do you use birth control in a month, right? And maybe that's continuous. Here, one issue is you don't know whether one causes the other because we have what's called a third variable problem. And the third variable problem can be described like this. There might be another variable that actually impacts both your variable 1 and 2. So this is what we call an extraneous variable, one that's sort of outside your scope of study. You're not looking at it in your study. So this extraneous variable might actually impact both variable 1 and variable 2. And so you might see variable 1 and variable 2 having a relationship together, like when one goes up, the other goes up, when one goes down, the other goes down. You might see that relationship, but that relationship might actually be caused by a third variable that's affecting both of those. So for instance, perhaps how much money your household earns affects whether you have a radio, but also affects use of birth control. Or the level of education that a woman has might affect whether they own a radio and whether she uses birth control. So those things might be caused by something else. So they look like they're moving together, but they're actually not causing each other. One sort of picture that I like to draw for my students, sort of mental picture, is this idea of, let's say there's two boats. There's a little blue boat, right? And there's a little red boat. Okay? And, whenever you see the blue boat sort of rise up in sea level, the red boat rises up in sea level. And when the blue boat goes down in sea level, the red boat goes down in sea level. But actually, both of those are caused by the water, right? It's not that the blue boat is actually causing the red boat to go up or down. It's really the water that's causing both the blue boat and red boat to go up and down, right? So in this case, this might be variable 1, variable 2, and the water is the extraneous variable, right? And it might really be this extraneous variable that you're not studying for some reason, that's really causing the both of these things, right? So that's always the problem in these other in non-experimental correlational designs. They always have this problem of the third variable that might be lurking back there. The third variable is often also called a confound. So something that's moving along with variable 2, the variable of interest, but it's sort of sneaking in there. We're not measuring it, so we don't know about it. Okay. And even so, even when you solve this third variable problem, sometimes you still have another problem that remains, and this is called the directionality problem. We don't actually know whether variable 1 impacts variable 2, or is it that variable 2 impacts variable 1? We don't know how to distinguish between those. And so that's called the problem of directionality. Even if two variables have a relationship to each other, either a positive correlation or negative correlation, we don't know whether X causes Y or Y causes X, right? And that's hard to distinguish in a correlational design or a non-experimental design. So let's say we take a correlational picture. For instance, here, let's say that variable 1 is women's education, a woman's educational attainment, right? And variable 2, let's say, is use of birth control. Well, we don't know whether a woman's education actually impacts the use of birth control, or perhaps it's that using birth control allows women to stay in school longer, right? So it could be either one of those directions, and we don't know from doing a correlational study. Let's say we ask women, how many years of schooling have you had? And we ask women, how often in a month do you use birth control? That would be a correlational design. But one issue that we'll have is we don't know whether X causes Y or Y causes X. And on top of that, right now, we also don't know whether there's a third variable lurking that might be more explanatory.